Welcome back. In this class, we'll delve into the essential skill of reading data from smart contracts. And this is a very crucial aspect of building your dApps because it allows you to access information stored on the blockchain. Whichever type of data you want to fetch from the blockchain, whether it's fetching a user's balance or retrieving transaction history or querying the state of your decentralized application, WAGMI provides the tools that we need to make this happen seamlessly. Now, we've already read from the blockchain. We've learned how we can read a user's balance from the blockchain using some WAGMI actions. We've seen how we can get a user's address and the network they are connected to using WAGMI and Web3 model. And then today we'll see how we can actually read from a contract. Now, before we dive in and start writing code to read data from our smart contracts, it's crucial to grasp the concept of application binary interface, or ABI for short. See, ABI serve as a bridge between your Ethereum virtual machine and your Angular application or dApps, enabling seamless interaction with all your smart contracts. So really, an ABI is a standardized interface for interacting with smart contracts that are deployed to EVM compatible blockchains. So basically, they are like a public-facing broker. They tell you which functions are available in a smart contract. They tell you the data types and the structures and then the return types that your contract exposes to the outside world. So in a sense, you can think of them as IntelliSense for your smart contracts. Now, ABIs matter because you can think of your smart contract as just one abstract, secure vault somewhere containing state, your contract state, and the functions that you've added already. But without an ABI, no one will know how to interact with your smart contract. No one can tell whether there's a function that is in your smart contract called withdraw, or there's another function that is called deposit. So ABIs matter because, number one, they give you function signatures. ABIs specify your function signature, which includes the name of the function, the inputs to the function, that is the parameters and arguments, and then the outputs, right? So they tell you which operations you can perform on a smart contract. They tell you the data encoding. When you send a request to a smart contract, the data that you send, the input data, needs to be encoded in a specific way in order for the EVM machine, the Ethereum virtual machine, to understand it. So ABIs define this encoding and they ensure that all your transaction and function calls are executed correctly. Now, ABIs also provide information about all the data types and the structure of everything, the return values from all your contract functions. So it tells you that, oh, this function called withdraw returns an address, or it returns a uint256 and it returns a string and all. Now, this is very crucial for reading and passing and the data that comes back from your contract. So to interact with a smart contract, you must obtain its application binary interface, the ABI. And there are different ways you can obtain it. Number one is that when you compile your smart contract code, the compiler will generate an ABI as part of its compilation process. So if you are using hardhat like we've been using, the hardhat makes the process very straightforward, and you will see the outputted ABI in the build artifacts folder. The second way that you can get the ABIs is that if you are working with a contract that is deployed on the mainnet, on the Ethereum mainnet or any other EVM chain, services, block explorers like Etherscan, they provide all the contract details, including the application binary interface. So if you go to the contract address on Etherscan or BSScan, etc., you'll be able to get the ABI. And then lastly, sometimes the ABI is not published anywhere. You can actually check the source code repository of the project or their documentation to look for the ABI and get the ABI. In this tutorial, we are using Hardhat, and so we'll be getting the ABI via the Hardhat compilation. So let's go back to our Hardhat project, the auction Hardhat project that we created earlier. So open your terminal and run npx hardhat compile to compile the project again. If you've been following along, your project should compile successfully. Okay, so it says nothing to compile. That's because it has compiled the project before and there's no new change in any source code file. So if you look in your folder, you will see an artifacts folder. This contains all the outputs of the compilation process. Now if you check under your contract folder, you will actually see the outputted ABI. The ABI in Hardhat, if you're using Hardhat, is usually in a file named the same name with the contract. So the lock contract, that's what you see here, lock.json. And then when you look here, you will see an ABI field in the JSON that was outputted. So the ABI is this array, which was assigned to this field. So you can always come here and just copy out this ABI and save it somewhere. So let's do that. Let's copy this ABI and let's add it to our Angular project. In our Angular project, let's put it under the assets folder. So let's create a folder called ABIs, and then let's create our first ABI. Let's call it NFT auction.json. So let's go back. I was copying the wrong one, so we don't need the lock. Let's copy the NFT auction ABI. So that's this to here. We save that, and let's create another file for the auction manager. So we'll call this auction manager.json. So we come back to our auction project. We expand the auction manager.sol folder. We go to the JSON file and we look for the ABI, which is this to this. We copy that. We come back to our Angular project and we paste that here. So now that we've added our ABIs to the project, we can import them into our project by doing NFT auction manager ABI. It's equals to require so this is the app components. So we require it from the assets folder, ABIs, and that will be NFT auction manager. Yeah. So That's how we bring in our ABI into our Angular project. But before we go ahead, there are two ways we can actually read from a contract using WAGMI. Now, before we go ahead, there are two ways you can actually read from a contract using WAGMI. The first way is using the read contract action. So the read contract action is an helper method based on Viem's read contract that allows you to just specify the address of the contract, the ABI, you pass in the ABI, and then you pass in the function name, and there is an additional parameter called args that allows you to pass in the input argument. So you use this when you just want to call a contract maybe once and you just need the data of a contract. So the second way is to create a contract instance. A contract instance is a type-safe interface for performing contract-related actions with the ABI that you specify and the address. So you can create a contract instance. You can create a contract instance by calling the getContract action, where you pass in the ABI and the address, and then you can, once you get a contract instance, you can then go ahead to call .read the function name of any of the contract functions that you want to call. So a contract instance has a read property through which you call read functions of the blockchain, and a write property through which you call write functions on any transactional type of function on the blockchain. So WAGMI is intelligent enough to use your ABIs to determine the type of the data that will be returned. So a contract instance also allows you to easily listen to events on that contract. So in order to go on with our tutorial, let's go back to our smart contract and let's run and add that node so that we can test locally. So we run and add that local node by running the command npx add that node. So once the node starts running, we're going to connect to the add that node from our MetaMask in our browser, and then we're going to read an auction from the contract, the auction count from the function, from the contract. So now the node is running. So add that node is running. Let's switch the network of our auction app to add that. So we do that going to so let's look for add that. Okay, so now we're on the add that network. One other thing that you should note is that the add that node that we run in our terminal is always reset anytime the terminal is shut down, which means that all the previous blocks, all the previous contracts that were deployed to that node will always be lost, and it also means that the current block number will no longer tally with the block number of your MetaMask here, because you can consider that every time you rerun and you restart the add that node, it will reset a state. So if you try to send a transaction from MetaMask to the add that node after it has reset, then the block numbers will not be in sync and your transactions will fail. So once you connect your add that again, you can go to settings, go to advanced, and choose clear activity tab data. This will reset the block numbers and every other thing and keep them in sync with whatever add that node is currently running with. So as you can see here, this current account has 10,000 at that Ethereum. And we're good. Now, like I said, our previous auction contract is gone, so we have to deploy another one. So let's run a deploy. Remember to deploy, we have a deploy script and we run that with npx add that run scripts deploy auction.js, and we specify the network as local host to make it connect to this ADAT node. Our auction manager was deployed to this address. Let's go back to our app components, and we are going to just quickly see an example of reading from that contract. So let's store this as the address, auction manager address, AUM address. We already have the ABI, which is this, and then we're going to use the first method, which is the read contract. And we're going to pass in so WAGMI is based off Viem, Viem, I believe that's how it's called. So sometimes you might see the same name in both WAGMI and Viem, but you have to make sure that you're calling the right function from WAGMI and not from Viem. If you call the one from Viem, it will lose its chain awareness. So read contract. Okay, so that has changed. So read contract, we are going to specify address to be NFT auction manager address. We'll specify the ABI, and the ABI will be the ABI that we imported here, NFT auction manager ABI. Then we specify the function name that we're interested in. And this time, we're going to just get the auction count. So let's go back to our auction manager contract. This is auction count. Remember, Solidity automatically creates a get method for public contract variables. So function name will be auction count, and it doesn't take any arguments. So args will be an empty array, and it returns a promise. So we could as well just make this async. So we could use await. However, we only want to run this when we are sure that we are connected to a chain. So let's move this into our subscribe method. So each time it changes the chain, it will rerun all this. So let's make this, and all we'll do here is log out the return data. So when we read this, auction count should be 0 because we've not added any auction. So you can call the read contract method, pass in the address, the ABI, the function name, and then the arguments. So there's a typo here. So ignore this error. But here's what we're interested in. You can see that it returns 0, n, which is a big number, But congratulations, you've read from the blockchain. Let's quickly see what's causing this error. I'll fix that. When the chain is connected, the account might not be connected yet. The account value might not be populated yet. So you can use any RxJS operator to combine the subscription from both the chain ID and the account to make sure that both of them are set before you then carry out any other operation. But since that's not what I'm demonstrating, I'll just ignore this and then I'll move on. So you can use the read contract to read from any contract, and that's the signature. Okay, so that's the first way. The other way that you can read from a contract is to get a contract instance and then read from the contract. So let's try that, which is contract is equals to get contract from WAGMI CORE, yes. So again, you specify the address, should be the NFT address. You specify the ABI, which is the NFT ABI. And you could also specify the chain ID if you want, in case you are not reading from your currently connected chain. But I'm going to ignore this. And that's it. So the address and the ABI. Now, once you have the contract instance, you can then call the read method to get the function name. So we're going to call read.auction count. Now, one thing you'll notice is that the type is messed up, and that's because when we imported the ABI, we used the require, and so the type information is lost, and WAGMI uses the type information to passes the interface in the ABI to determine the type information. The easiest way to just get around this is to, because we know that the type is correct, is to just ignore this. Tell TypeScript to ignore that. So let's log that out also. So you can ignore some of the other errors. My internet is spotty, but you can see here it also returned the correct value, which is 0. So again, you can use any of these two ways to read from a contract on the blockchain, on an EVM compatible blockchain. You can use read contract, or you can use a contract, create a contract instance and then read from that contract instance. So this allows you to easily do, assuming there were other methods that you wanted to read from, you could just also call from the same contract instance and do your read and read from your contract. And you could pass in the arguments if you need some arguments. You pass them in an array. And that's how you read from contracts on the blockchain with WAGMI and in Angular. Now that we've seen how to retrieve data from the blockchain, one other thing that we'll need to master will be how to easily interpret and put that data to meaningful use and in a meaningful display to our Angular users. So, smart contracts return data in various forms, and dealing with these data types require an understanding of the intricacies of these different data types. So for example, you will encounter basic data types like integers, uint, int. You will encounter booleans, you will encounter addresses, and you will encounter bytes like byte 32, byte 16. And you need to understand how to handle this type of data. So for example, if you are dealing with smart contracts that deals with tokens or the Ether currency, more often than not, you will have to do some conversions, and the conversions are not always straightforward because some tokens do not use 18 decimals. So some tokens have 6 decimals, some have 2, some have 18, some have 12, and so conversion between those type of tokens will require an understanding of Ethereum maths, right? So, for example, if you retrieve a balance from a contract, you can't just display the balance the exact way that you retrieve it. So, WAGMI through Viem provides you some utility functions that help you to format those data and present it in a good way. For example, we have format Ether, and this is from the Viem library. Now, the Viem library is what powers WAGMI behind the scene and is written by the same team. So you can, when you install WAGMI, the Viem library is also installed for you. And so you can use format Ether, for example, to format a big number to this. Now, this is assuming that this digit here is Ether, so which means that it is using 18 decimal places. You could also have format units that allows you to format a number based on the number of decimals. So if you have this type of big number as the balance of a token and the decimal of that token is 9, you can use format units to get the actual number of tokens that the wallet has. So you can use format units, pass in the big number and then the number of decimals. You also have pass Ether. So for functions, for example, that expect an amount for a token, you can use pass Ether to do some conversions and send it in. Pass Ether is a shortcut for this pass unit, which allows you to now specify the number of decimals. So as you can see, pass unit gives you this, which was the same with the format units that you saw earlier. So you also have arrays. Smart contracts can also return arrays of different data types. So you might receive an array, and in that array, you have a list of user balances, maybe a list of 5 different addresses balance, or you can return an array of a struct containing complex data. Structs are user-defined data structures. Again, we've treated structs earlier, but you need to understand the structure of the struct to be able to extract the relevant information. And then you also have enums. Enums represent a finite set of constant values, right? So smart contracts return enum values as constants, 0, 1, 2, 3, numerical form. So you will need to convert the enum value into an human readable form. So it's a critical skill understanding how to interpret and use smart contract data. You will need to do some typecasting because you might not get the data from the smart contract in the appropriate data type for your Angular application. So if you are expecting a number, it might return a big number, so you might be you might have to cast it to an integer in your code before you can use it in Angular. Then always anticipate errors. There will always be potential errors. So sometimes you are expecting data, but the data is not present, or the data is not present in the expected form that you're expecting it to come in, or the type. So make sure that you have robust error handling in place, and make sure that you validate data to meet all your requirements and your security standards. So lastly, make sure that when you display the data, it's presented clearly and in a form that is useful for your users. So you can't display a big number directly on the auction app, for example. You will have to convert it into a numerical form and use maybe some form of format it well so that it includes maybe 1,000 separator, and you can do that using different pipes that are available in Angular, or you can write yours.